Welcome to the AVL Simulation Podcast, where engineering missions take off. Join us as we navigate the evolving universe of digital engineering and simulation in the automotive and energy industries. Explore the forces shaping the AVL simulation software suite and hear how pioneers across the globe use it to outpace competition. Strap in. Our mission begins now. Welcome your host to today's episode.
Not all pioneers make headlines. Some build the infrastructure that powers progress behind the scenes. I'm Max Sommer, and today I'm joined by Luigi Giordano, Director of Electrification Application at AVL Instrumentation and Test Systems. With decades of experience spanning service, sales, and strategic leadership, Luigi has helped shape how electrification is tested, validated, and understood. In this episode, we'll talk about bridging the gap between testbeds and simulation, the evolving role of emulation in electrification, and why modeling battery aging may be one of the most critical challenges of the future. Let's dive in. Luigi, we think of AVL as a technology universe. Where are you located in this universe?
Universe, you're right. We are doing so many things in AVL. Actually, I'm together with my colleagues responsible for testing methodologies for all the electrification test systems. So we support with our knowledge, with the requirements, with use cases, with application, the colleagues realizing and designing test systems.
Great.
And they collect our inputs and then they decide if it makes sense to develop a solution or not.
So you entered AVL very early, long time ago if you want.
June 91. Yeah.
That's amazing. And then even before that, I think we had in our preparation talk, you got in touch with electromobility. How was that?
That's true. As I said before, in the family I have two brothers. We all three have studied electrical engineering. My father did the same in the 50s. And my father had bought an electric car at the end of the 70s. So we still have it in the garage in Italy. And this passion for electromobility comes from a long time ago.
So does the battery still work is the question.
No, there is no battery. It is a car which based on lead acid batteries, and at the moment the battery is not installed.
Great. Well, that was an early first experience and
yes.
Just a great story. What actually got you into engineering in the first place?
Curiosity.
Mm-hmm.
Since I was a kid, I was curious to know how things are working. And if you are curious in the physical aspect, in the matters of objects and tools which we're using today, engineering is a good point to start. Originally, I had the idea to do electronic. Mm-hmm. Of course, we speak about the 90s, not the technology of today. But I rapidly changed it to electrotechnica.
Yeah. And
electricity was interesting for me.
And it runs in the family, you said, right?
Yeah, my two brothers are younger than me, then they follow it.
Great. You are in a central position in your area of AVL. What do people approach you for? What makes you the center of your constellation?
Yeah, definitely knowledge, not only my one, but of the team. Knowledge and the availability to collect and share this knowledge in a way that we can help to give a direction to our development and to support our customers in the most efficient way to perform the testing and the validation task. So we are basically delivering knowledge.
Now, given your experience, tell our audience maybe a habit or a trick that you use that makes your workday 10 times better.
A trick? That's a difficult question. I don't think that there are tricks. Let's say, in our case, we are confronted with a very wide portfolio. We are doing a lot of different AVL delivers a lot of different type of test equipment with many different use cases. So the trick is to listen to customers, have a good network of experts from the field, from the users, and capture as much as possible all those inputs. So, and by capturing these inputs, then with my team, we can then come with ideas, new solutions, or new concept how to perform the task which a customer needs to solve.
When I talk to an Italian, the morning routine you might have usually starts with a coffee. Am I right? But is there something beyond the morning coffee that you do on a daily basis that gets your start going? Give us some insight into your daily routine.
Well, I have changed a bit my attitude. I'm there living in Austria since more than 20 years. So actually I start with the tea. This is maybe coming from the several trips I did in China. Changed a bit the attitude. And China is actually one of the reasons why, or one of the things which I'm doing at first when waking up. Typically before drinking the tea, you look to the telephone, which emails are coming, which emails arrived overnight, and typically they are the Asian ones. And the electrification is in large part happening in China, Korea as well. But these are the first chance of business which I get in the morning. This is the real morning routine. Wake up, have a look what happened in China, and then start the day.
So if you look at what happened in China, that sounds like your day kind of goes around the globe with all the different time zones that you're involved in. How do you manage that? That seems like you would be on and on wired 24/7.
No,
our business goes around the globe.
It is true that the business runs all over the globe, whereby depending on the type of business, we have focus areas more in Asia or in Europe or in US. Depends on which kind of testing solution we are speaking about. And definitely I'm not wired 24 hours a day. I also have a private life. But it is true that I'm regularly checking emails and filtering what it is important. And when there is something urgent, I also filter if can be sorted out immediately or not. Yeah. If not, I stay quiet.
So we ask our guests questions about their work, but also we are interested in what do you do to relax? What do you do to take a break from work? What do you do to recharge your batteries?
Very successful. Well, I like to read a lot, but the really effective measures to recharge and to free up the mind is running.
Okay.
So, and of course, I'm not the youngest anymore, and I don't invest like some crazy colleagues several hours a week to run, but I take my time, maybe it is 2-3 hours a week, and this is really freeing the mind, and this is really recharging.
Beautiful. Well, since this is a podcast about simulation, what role does simulation and what role do simulation and virtualization play in your everyday work?
Yeah, the role, I can tell you, over the 34 years increased dramatically. The simulation is definitely the tool which helps to speed up and make more efficient the testing and the validation. It is, for example, thanks to emulation, the real-time emulation of the missing components in a testbed, which helps to validate the functionality of a component at the very early stage. So, for example, if you the customer has to develop an electric motor and is willing to tailor the thermal management of the electric motor to a specific test track. Let's say the classical, in Europe we always speak about Nürburgring. Mm-hmm. So the simulation, the emulation in real time applied to an e-motor testbed gives the perfect possibility to calibrate and tune the e-motor to the thermal limits when running this specific use case. So emulation is definitely important to perform this kind of validation at a very early stage.
You mentioned the combination of testing and simulation. This is a big topic here at AVL and in this industry, obviously, physical testing towards virtualization. One could say there is a battle between them, but I think here at AVL, we believe that there is synergies and then there is a collaboration and the combination of it. Give us some insight of a historic breakdown. Where did this combination of testing and simulation start? Where are we today? And where do you think is the future of these two fields working together?
Yeah, but if you look to the history, let's say first we started with real-time emulation on the testbed, because AVL was from the very late 90s focusing on moving some tests from the road to the rig. Mm-hmm. So performing for drivability or critical maneuvers on a car or a naked powertrain in a testbed in a more reproducible way than on the road. So already at the end of the 90s, we were testing how a car is cornering on a wet surface or an iced surface. So, this was the very beginning, real-time emulation, mimicking what it is the missing part in the testbed. In this case, were the tires, the asphalt, and the environment. And this developed more and more. Today, we can emulate in real-time electric motors with all the related harmonics and behaviors and thermal behaviors of the electric motor. We can emulate batteries when testing an inverter, and so on and so on. So we went deeper and deeper inside the vehicle and the powertrain in emulating the reality, which is missing in the specific test. The simulation comes, I cannot tell you when started, but is definitely in the meantime also a relevant part when we think how we collect data. And, for example, we try to create offline a aging model of battery cells. So in this case, virtualization and simulation helps to change the way we are testing the battery cells, collect the data in a more efficient way, in a shorter way, and then with calculation to create a mathematical model which can be used to design the module and the pack. Mm-hmm. So, and this, again, I cannot tell you when it started, but this is definitely in the meantime also a relevant part of the combination of testing equipment and emulation. And in the ideal world, of course, we tend to replace more and more real test equipment with simulation. So it is a full cooperation, but of course, we try to help to increase the simulation, because in the end, the customer needs to reduce the time needed to validate the component.
But at the end of the day, no matter how far we look into the future, you still see physical testing being part of the development cycle.
As of today, yes. There are things which cannot be perfectly emulated. So for specific test, it is moving more and more to the component level. Depending on the powertrain, there are powertrain types, propulsion system types, which need less testing on the system level, but on the component there are still And then it is always a trade-off between the effort to digitalize, virtualize the component or test it in real time.
Mm-hmm. And if you stay in the future, where do you see the biggest untapped potential for simulation? Where do you think are we, where we are not there yet, but you see like if we can unlock this lever, this will be a game changer for our industry?
Again, I refer to development time of a vehicle because this is what influenced the decision of our customers. And if you take the example of battery, typically to develop a battery system for a passenger car, in base case takes 36 months. And a large portion of this time is dedicated to durability testing. Okay. So there are the example I mentioned before exactly helps to reduce by around 20-30% the duration of a durability test. But if we will be able to come with a different approach, which will, with simulation, help to further reduce the time, will be even better. Yeah. So I will say that where there is a lot of potential is in durability testing.
Mm-hmm. Now, if you had a traditionalist opposite of you who says everything is testing and I'm in the testing world and I do it like I've always done it, how would you convince or what would you say to this person to get him more on this virtualization path, to convince that there is maybe a better way, if you want, to do things than 10 years ago, 15 years ago?
Okay. Well, it is easy to answer. The typical two roadblockers when you are trying to convince a traditionalist to use more virtualization is to provide evidence that the simulation and the emulation are accurate. So it is important to demonstrate how far away we are from the reality. Because, of course, if we are 50% away from the reality, then does not help the emulation. But if we are near to 1%, this may be definitely the point where you can convince the counterpart. And the second critical issue is the effort to parameterize the model. And because when emulating complex systems, the effort in generating the parameters may be too high for the customer. So, but these are the two topics. So if we can demonstrate that the emulation is accurate and that the parameterization can be assisted, like, for example, we are doing by having automated test runs measuring a real battery, generating the parameters which we can then use in the emulation, then I think we can convince the customer. No?
Maybe at this point, let's focus on some hot topics out of your daily work. What are use cases that are customers seeking for? What are the hot topics that you work on a daily basis? Where is this industry going?
So durability we mentioned before. Hot topic is the calibration of the inverter connected to an electric motor. The electric motor, modern electric motors, they also rely on complex software running in the inverter in a way that they are operated in an efficient way, but still delivering a top performance without wasting too much energy in it, and especially not being too noisy and so on. So this means that also when tuning the operation of an e-motor, you have a complex system to calibrate, and the calibration assisted tools which we have in our portfolio, the simulation, these are definitely of help in achieving the specific target performance that the customer have. And this is especially useful because in electric cars, the electric motor may be used in different ways depending on your driving condition. There are OEMs, for example, tuning the electric motor to be super efficient, but to generate waste heat when you are approaching a fast charging station, because you need this heat to warm up your battery, which needs to achieve a specific temperature before being fast charged.
Yeah.
So this increase also the complexity of the operation of the electric motor is one example of having multiple control modes on the motor. And with our test systems and with our virtualization tools, we help the customer to speed up the calibration of these many different systems.
If I listen, I hear a wide variety of topics. It goes from A to Z, everything electrification. Let's change the focus here and look at your team. What roles do you need in your team, and what are you looking for when hiring new people? Or what are you looking for in your team members? What, in your mind, in this field, makes a high-performance team?
Yeah, in the team I have all brilliant engineers. So they are all technical profiles, and they come from the industry. So each of them has a specific expertise on a portion of the portfolio we have. And we have, for example, colleagues which have a deep knowledge on how electric motors are designed and validated. I have one team member which is a brilliant engineer on power electronic. He's a very active patent generator in AVL. And I have a colleague which has a chemistry knowledge about battery cells. So his knowledge is extremely useful, for example, in assessing the degradation and the risk profiles of different batteries when tested. We have not spoken about safety, but when testing components, you have also to be on the safe side. And I have then one colleague which has expertise in environmental and abuse. He was also member of a norming group in the Dean for charging topics. So in my team, we have real experts, technical experts.
Now you have the skills, the experience. What do you look for in their spirit, in their everyday approach? Is there something that you say, is it, I don't know, hard work or discipline, curiosity maybe? Tell us a little bit about the traits, the personality traits that you're looking for in order to keep up with the ever-evolving electrification world.
Yeah, I think the key is to have engineers which love the method they are representing. So I'm pretty sure that the colleagues, they are all experts on a specific part of the portfolio, and you can recognize they keep themselves informed also in the free time what's going on the market, and so they do it not only because it is a job, but because it is a passion about those topics. And where they have to manage a bit the stress is when we decide, because typically our job is to give suggestion for the development of new solutions. Sometimes we miss the market trend, and then we are running to deliver knowledge inside the customer projects. We have pilot customers. Customers are informed that we are realizing something new for them. But in those cases, of course, we get the time pressure to support the other teams which are realizing test systems. And there, of course, we have to manage also time pressure. We have to manage to provide the right technical information so that the colleagues can evaluate the risk profile of decisions. And there, of course, there is a bit more uncertainty.
Now you have all these experts around you. How do you manage collaboration? Or are these individual islands that work on their own thing? But how do you manage maybe the exchange of know-how, the exchange of experience, the exchange of ideas probably? How do these experts in their own field come together and work together?
Yeah, this is not easy. We have definitely more distance between the teams realizing the test beds, because they are, of course, focused on their job. We have the luck of being naturally all together, so we definitely naturally share the information together. And we have between the colleagues a bit of overlap in our responsibilities, but definitely we do our best to share all the information. And then having shared in our team the information, then of course we can help to share this information down to the segments realizing the test beds.
Mm-hmm. We're getting closer to the finish line of this very interesting podcast. We started with more of an introduction and getting to know you, and we will end and finish this podcast in a similar way. After so many years on the job, what have you taken away that you wish you would have never learned?
Actually, of course, 34 years of AVL, we had some challenges. I personally had some difficult times technically to solve problems, but I think that I will not skip anything, because even the most difficult problem, the most stressful situation is a chance to learn something. And it is only by learning, by experience, that you can better take decisions afterwards, in my opinion. So I will not say that there is something which I will skip.
I will add here from my personal background from sports coaching, one of my favorite quotes is, everybody's always talking about wins and losses. But as a coach, if you approach your team, if you get the philosophy and the idea of either you win or you learn, I think you're on a good path to ever develop and always develop and move forward. So from the defeat, learn the most out of it, and don't see it too negative, but actually see it as a learning opportunity.
Definitely.
And this is, how I also gotten to know AVL, when things are not always great, but what can you learn, and how fast can you learn, and how fast can you change the situation? This is a very great trait about this company that I have experienced over the almost a decade that I'm here now. So last but not least, if you had to give your 20-year-old self some advice to make a career in this industry, what advice would you give yourself?
Good. If we think to the actual technological trends which are in front of us, I will, of course, suggest him to still do electrical engineering, because electricity is becoming more and more important in the energy portfolio of every country. We see the growth of the renewables. And the second suggestion would be related to artificial intelligence, machine learning. There, definitely a young engineer must daily use the new tools and learn how to use them at their best. Because all these capabilities which are available today and were not available at my time, they are dramatically enhancing the capability of an engineer. So use all the tools available. Don't be shy. Don't be afraid that the tools may replace you. Use them. Yeah, this would be the suggestion.
Great. Luigi Giordano, thank you very much for your time.
Thank you for having me. Thank you.
Thanks for joining us on the AVL Simulation Podcast, where engineering missions take off. We hope today's journey through the world of simulation sparked new ideas and perspectives. To keep up with future episodes, subscribe wherever you get your podcasts. And if you're ready to accelerate your digital engineering mission, visit avl.com for more insights. Until next time, keep simulating, keep innovating, and keep pushing the boundaries.